All right, so I decided to go ahead and switch over to using the screen instead of the uh, blackboard or the whiteboard because I figured this would actually be maybe easier to show on the screen because this is more like what you're going to do in reality anyway. So here's what we have. We're taking a 4-byte value, like you might find in the well, an IP address is like this, but with an IP address, each separate piece of it is each byte is one value, and you just string them together with dots. But when you do the sequence numbers or the acknowledgement numbers in TCP, you're going to need to be able to take these 4 hexadecimal bytes and convert it into one giant value in decimal. So we're going to learn how to do that here now. We just did the other one. Converting to binary and also converting to decimal with 2 bytes, but now we're going to do it with 4. So the same thing we saw there applies in that, oops, that's not right. I had to do this. Okay, so powers of 16. So this is 16 to the 0 power because that's how place numbering systems work. Is that the first place, if it's base 16, which is what hexadecimal is, the first place is 16 to the 0. 16, anything to the power of 0 is 1. 16 to the power of 1 is just 16. So this is the 1's place, the 16's place. Over here is where it gets a little bit more interesting because we have 16 to the power of 2, 16 to the power of 3, 16 to, oops, let's just do it that way, 16 to the power of 4, 16 to the power of 5, 16 to the power of 6, and 16 to the power of 7. And so 7 is the highest power here because we have 8 places counting from 0 to 7. So that makes sense. So for each of these, you can calculate what the value is of that place, right? This is the 1's place. This is the 16's place. 16 times 16, that's why I have the calculator up here on the screen, is 256. That one I knew. As well as multiply by 16 again, it's 4096, right? Multiply it by 16 again, and you've got 16 to the 4th power. It's 65,536. I'm going to start putting some commas in here to make it easier to see the thousands, and I'm going to have to decrease the font size of this row because it's about to get really big. Times 16 again, and it's 1,048,576. Multiply by 16 again, and you've got, sensibly enough, 16,777,216. And then multiply by 16 one last time, and you've got 268,435,546. And there you go. That's okay. Let's shrink it down a little bit more yet. Okay, so there you go. That's what the values are, right? So just like in the numbers we're used to, you got the 1's place, the 10's place, the 100's place, the 1,000's place. Here you've got the 1's place, the 16's place, the 256's place, the 4,096's place, and so on. So there you go. That's what you get. So the way to do this then is for each of these, you just have to figure out what the value is of the digit and multiply it by whatever place that is, right? So the value in this place is 2. It's in the 1's place, so 2 times 1. The value here is 15. It's in the 16's place. So we'll use the calculator for that one. It's 240, right? So again, we're doing this with just a regular calculator, no programming calculators, all right? This is in the 256's place. There's a 3 in that place, and that's going to be 768 as the value of that place. And obviously, I'm going to have to shrink. What did I end up using here? size 9 font. So let me go ahead and shrink this down to a lower, smaller font too, because we're obviously going to have the same thing going on here, only more so because we're multiplying. So we got a 4 in the 4096's place, and that's 16,384. We've got a 9 in the 65,536's place, and that's 500 or 589,824. Right, so you see what we're doing here, right? So C is what? What's the value of C? A is 10, B is 11, C is 12. Right, so we got 12 times 1,048,576. All right, the easy thing to do here is copy and paste. Easier than typing them out. Wonderful thing about doing it all on screen with a calculator that's on your computer. We've got A, which is 10, right, in the 16,777,000 place. This one, I don't even need a calculator for this one because it's just multiplying by 10 because A is 10. So it's 10 times this. Add a 0 to the end. And then, of course, since we are using commas, we got to shift all the commas over. That's not right. There you go, 167 million. And then here it's 2 times 268,435,546. Or 456, sorry. And the answer is, and I'm going to just copy and paste this one again, then put in the commas. I like the commas. It makes it easier to see what we're dealing with. All right, so that is all the values of each place, right? So this is the value in the place. This is the value of that place. So you multiply them together. And then what we'll get below, I'm going to do another row below, is we're going to add them all together, right? So I already have, let's see here, table design. Let's get rid of that border up there, make it nice. And there you go. All right, so we're going to add them all together. I guess I don't really even need another column for that. Okay, so we're going to add all of these together. I already have this value in my calculator. It's the biggest one, the most annoying to have to keep entering, so I don't have to enter it again. Oops. Okay, so I go to my calculator. I add 167,772,160. I add again 1,200,000. Oh, sorry, that's actually not 1 million. That's 12 million. See, I have the comma in the wrong place. So it's 12,582,912. Add again 589,824. Add again 16,384. Add again 768. Add again 240. Add again the 2. And then that's what that equals. And I can copy it, and I can paste it down below. Bing! There you go. Put some commas again, makes it easier to tell what the value really is, so you know which places you're dealing with. So it's 717,833,202. And that is the value, the decimal value of these 4 bytes all put together as one big long 4-byte long value. That's what you get. So that's not that hard to do. You can do it with a regular calculator. Let's go ahead and use, as long as we're sitting here at this wonderful calculator that's capable of doing it, let's go ahead and use the programming calculator as well to double check our work. So I'm going to put it into hexadecimal mode. I'm going to type in our number 2AC943F2. Right, that's the number here we have in hex, and then so we can see what the value looks like. Right, it's 4 bytes long, so we can see what the value would look like in binary. You can, by the way, in Mac, you can show or hide the binary, and then I'm going to change it to decimal, and it's 717,833,202. Woohoo! We did it right. So there you go. That's all there is to it. Not that hard. It's a little laborious, but again, it's not something you have to do every day. It's not something that, this isn't what the pros are doing every day. But doing this gives you the confidence that you can do this, that this is something you can do. You can work it out longhand. You can work it out with a calculator. It takes time. It takes patience, but you can totally do it. And you understand what's going on. You understand what the operations really are. I feel like when you do the operations by hand, you understand what this really all represents. Whereas if you just plug into a calculator, you don't have to understand what it really is. And I think there's a lot of value in that. Once you learn to do it with the calculator, you're never going to do it with the calculator in real life. That's okay. The only way you're ever going to do it with the calculator in real life is if you become, I don't know, a professor, and then you'll do it again every semester, over and over again with a different group of students. But other than that, you'll probably never need to do this again. It's just not something the pros normally are doing. They allow the machines to do the work for you. So it's one thing to allow the machines to do the work for you on a daily basis, but it's another matter just to let the machines do everything for you and not even understand what it is they're really doing. I think there's a lot of value in that, a lot of power in that. So next up, we're going to give you an exercise to do that will allow you to practice this.